Hey everyone, how are you all? I hope you all are doing good. So in this class I am going to explain about the periodicity of modern periodic table. That means trends in periodicity of modern periodic table. In my previous video I have given the introduction about groups and periods. That means modern periodic table. I have given the introduction about the modern periodic table. So without making any delay, we'll start the trends in periodicity of modern periodic table. So first one, valence electrons. Children, see what is valence electrons? I already told you the number of electrons which are present in outermost shell, Okay, for example, if you are having a calcium, how you are going to write? See, you are going to write the shell like this. Okay, so 2, 8, 8, 2. So this is the outermost shell. Okay, so K is the inner shell, L, M, these are the inner shells, and N is the outer shell. So whatever the electrons which are present in the outer shell, that is called as a valence electrons. So now what it is going to happen when we will talking about the valence electrons, when we are talking about the valence electron in the groups or in the period. When we are talking about the groups, all the group members, okay, all the elements which are present in the same group, a particular group, the elements which are present in the particular group containing same number of valence electrons. Clear? But when we are talking about the period, in the period, one moving left to right, okay, one atomic number it is going to be increases. Okay, so due to that what is going to happen? One extra electron is going to be added, so that moving left to right, in the period, what it is going to happen? Valence electrons will be vary by one number. Every one atomic number changes, one valence electron it is going to be added. Clear? So you can take many examples for this. You can take many examples. So if you can take second period elements like lithium is there, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So what is the atomic number of lithium? 3 is there, beryllium 4, boron 5, carbon 6, nitrogen 7. Clear? So you can write the electronic configuration of lithium, that is 2, 1, beryllium is 2, 2, boron is 2, 3, carbon is 2, 4, and nitrogen is 2, 5. These are the things we discussed in our previous video, and also in the 9th standard we have studied these things, how to write the electronic configuration and all. So see here, this is the valence shell electron. Okay, see here 1 is there, here 2 is there, here 3 is there, here 4 is there, so here 5 is there, and it will be so on. Clear? So what we understood? When we moving left to right, valence electron increases by 1. Okay, one electron will be keep on increases. Clear? But if you are talking about the groups, valence electrons will be remain same. For example, when we are talking about the elements like lithium, first group elements, lithium, sodium, potassium. If you take lithium, atomic number is 3, sodium atomic number is 11, potassium atomic number is 19. Electronic configuration of lithium, if you are going to write, it is 2, 1. Okay, so sodium if you are writing 2, 8, 1. Okay, potassium if you are writing 2, 8, 8, 1. See, valence electron is same. That's why I said in the groups, moving down the group, what it is going to happen? Valence electrons will be remain same. Clear? That's why their physical and chemical properties will be remain same. There will be a little bit variation in the physical properties, but chemical properties will be same in the groups. But if you are talking about the period, due to the increasing valence electrons, when we move left to right, what is going to happen? Their chemical properties are not same. Clear? So this is something about the valence electrons. Clear? By knowing the valence electron, we can easily find out the valency. Clear? So what is our next topic? That is valency. So valency. So children, how you are going to find out the valency? By knowing its valence electrons. When you are talking about the valence electrons, during that time I said the outermost electron present in the element. For example, if you are taking you want to find out the valency of elements which are present in the group and period, whatever the elements which are present in the periodic table you are going to take. So here we are going to do it for 1 to 20. I will do it for 1 to 20. Clear? So as of now we need this much only. Okay, in the higher classes we are going to study for the remaining elements, but here we need to concentrate for 1 to 20 elements only. Clear? So hydrogen is there, atomic number is 1, so valence electron will be 1. Okay, what is valence electron? 1. So valency is equal to 1, it will come. Why valency will 1? See how you are going to do in order to find out the valency of elements which are having valence electron 1, 2, 3 and 4. It is having the same number of valency. It will be having same number of valency. Like if the element is having 1 valence electron, the valency will be 1. If the element which is having valence electron 2, then the valency will be 2. If the element which is having valence electron 3, then the valency will be 3. Okay. If the element which is having valence electron 4, then valence will be 4. But after 4 means if the valence electrons are 5, then what you have to do? We need to minus with the 8. 8 minus 5. Why? What is the 8? 8 is the maximum number of electrons that can accommodate in the shell. Okay, according to Bohr and Bury. In the structure of atom 9th standard we have discussed this. So if the 6 valence electrons are there, then what you are going to do? 8 minus 6 you are going to do. If 7 valence electrons are there, then 8 minus 7. If 8 valence electrons are there, then what you are going to do? 8 minus 8 you are going to do. Clear? So this is the way how we are going to find out the valency. Clear? So I have given hydrogen now. So if you are talking about the helium, atomic number is 2. So its valence electrons will be 2. So in the helium it actually K shell is there. K shell, the capacity of K shell is 2. So the valency will be 2 minus 2 you have to take. Why 2? Because the capacity of electron can accommodate in the K shell will be 2. The maximum number of electron that can accommodate in the K shell is 2. Hence the valency is going to be 0. Because and also why its valency is 0? Because helium belongs to the 18th group. Whatever the 18th group elements are there, helium, neon, argon, krypton, xenon, they all are having 0 valency. Hence it is also called as a 0th group. They also called as a 0th group are inert elements or noble gases. Okay. So whatever the remaining elements are there, that elements either they want to lose their electrons or gain electron in order to become a noble gases. Okay, because all the elements need to be stable. So what they will do? Either they can lose electron, either they will be gaining electron to become an octet. What is octet? The number of electrons which are present in the outermost shell will be 8. If 8 electrons are there in the outermost shell, then it is called as an octet. Clear? So for that octet, what it will be doing? Elements will gain electron or lose electron, and sometimes they will simply share. Okay. So the valency of the helium will be 0. Clear? So lithium atomic number is 3, valence electron will be 2, 1. I already said if 1 will be there, then valency will be 1. Clear? So if beryllium is there, 4 atomic numbers, so 2, 2, valency will be 2. If you take boron, 2, 3 will be coming, atomic number is 5, so 3 valence electrons, so valency also 3. If you are taking a carbon, atomic number is 6, so valence electron 2, 4, so you no need to do 8 minus 4, simply you can write 4. If you are talking about nitrogen, it will be 2, 5, so that means 8 minus 5, it will be coming 3. Okay, so if you are talking about the oxygen, atomic number is 8, 2, 6 will come, 8 minus 6, 2 will come. So that means what, children? This valency means what? Valency means combining capacity of an atom. Okay, so how it will be holding, how it will be taking the electrons, how much electrons it need to be take, it should be share, it should be gain a loose electron in order to become a noble gas, in order to become an octet. Say for example, this oxygen is there. See, if you are writing the electron dot structure, see, it is having 6 outermost electrons. Okay, so how much electrons it required? 2 electrons it required to become a stable. If any element is donating 2 electrons to it, then what it is going to happen? This oxygen become stable. So you can ask one more question that, sir, here 6 is there, can it lose 6 electron and it can become like helium? So because helium is outermost electrons is 2, so it is also noble gases. Okay, see, for the oxygen 2 possibilities is there, means 2 noble gases are there. One is helium, one is neon. So neon is closer to it. Neon is very closer to it because after oxygen fluorine will come, then neon. So how many electrons it should be gain? So one is fluorine, means 1 electron, and neon. So 2 electron difference will be there. If it is gained 2 electron, oxygen will become just like a neon. But in order to become like a helium, it want to lose 6 electron. So the losing of electron, how many? That to 6 electron is difficult compared to gaining of only 2 electrons. Okay, whatever the valencies you are seeing over here, either they will be losing that electrons or they will be sharing or they will be gaining that electrons to become a stable. For example, lithium is there. Okay, lithium, what I said, atomic number is 3, hence its valency will be 1. So valency is 1 means what? Its nearest noble gas is helium. Its nearest noble gas is helium. Okay, so then neon is far away. Okay, what it is going to happen? If it lose 1 electron, because it's 2, 1. If it is losing 1 electron, it will become like an helium. So it will become stable. But if it gains 7 more electrons if it is gained, then it will become like neon. So gaining of 7 electron is difficult to comparing to losing of 1 electron. Clear, children? So same trend you can do for remaining elements. Clear? So fluorine, you can take fluorine. What is the valence atomic number? 9. So 2, 7 is there. Okay, so 8 minus 7, valency will be 1. That means 1 electron is needed to become a stable. Otherwise 7 electrons it needed to be loose. Then what is going to happen? It will become stable. So I already told, if the element is to be gain electron or lose electron, they need energy. Okay, so but when you are talking about only 1 electron to gain, that is easy compared to 7 electron to be loose from this. Clear? So hence what it is going to happen? Simply it will gain 1 electron to become like a neon. Clear? So your homework will be 11 to 20 you do. I said 1 to 20 I will do. But what you will do now, based on this, take a screenshot of this. Okay, how to do? You just have a look on this. Okay, you can take the screenshot of this, and based on this you can do for the remaining 11 to 20. Okay, sodium to calcium you can do. Same manner you can do. So by this, I hope you understood the valencies. Okay, so what is going to happen to the valency now? You have to learn that one. So in the groups, what is going to happen to the valency in groups? Now you understood what is valency, how to find out the valency. Now you need to understand what is going to happen to the valency in the groups and in the period. Sir, in the groups, valence electrons are same. If the valence electrons are same means what? Valency is also going to be same. That means in the group, valency will be remain same with all the elements. Whatever the elements you take, valency will be same. So all the elements of a group of the periodic table have same number of valence electrons. For example, if you are taking first group element, all the elements having valency 1. If you take the second group elements, all the second group elements having valency 2. If you are talking about the 13th group elements, all the 13th group elements having valency 3. If you are talking about the 14th group elements, all the 14th group elements are having valency 4. Clear, children? So now, what it is going to happen to the valency in the period? So I already told there will be abnormality in the valence electrons. That means there will be an increase in the valence electrons when you move from left to right. So due to that, what is going to happen? On moving left to right in a period, the valency of elements increases from 1 to 4. First it will increases to 1 to 4, then it will decreases. It will decreases to 0. Okay, so I will take one period and I will explain that. If you are talking about the second period, children, so the elements are starting from the lithium. So lithium atomic number is 3. So 2, 1, valence electron is there, so valency will be 1. Clear, children? Next, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Clear? So all the atomic number you write. So 3 is there, 4, 5, 6, 7, 8, 9, 10. So what is the valence electrons of beryllium? 2, 2, I already told, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. Okay, so based on this we have to find out the valency. Clear, children? So I told 1 to 4 is there, then you need to minus with anything. Okay, so if 2 valence electron is there in the beryllium, so 2 valency will be 2. So if boron is there, valency will be 3. Carbon valency is 4. See, it is increased 1, 2, 3, 4. Now what we have to do? Valence electron is 5 is there. So I already told you need to minus, because the maximum capacity of electrons can be accommodated in the M shell. It is 8. So that what you have to do? You have to minus with 8. Clear? Now see here, 8 minus 5 if you do 3. 8 minus 6 if you do 2, 8 minus 7 if you do 1, and 8 minus 8 if you do 0. So then what you have to say? Valency, when you move left to right, it will be first increases, then afterwards it will start moving left to down or left to right. What is going to happen? It will be decreases 3 to 0. Clear, children? So this is something about the valency in groups and period. Now by knowing the valency and by knowing the number of shells, we can identify the groups and period. Clear? So we will be doing that now. By knowing the valency or by knowing the valence electrons and number of shells, we can find out the group number and also period. So listen carefully, children. Here very important thing it is. Okay, in the exams many times they have asked. So in order to find out the group, they have given simply the element they have given. For example, they have given the element magnesium. Okay, you know what is the atomic number of magnesium? That is 12. So what it is going to have? What you are going to do now? 2, 8, 4. That you are going to write the 2, 8, 2. First you are going to write its electronic configuration. So what I said, by knowing its valence electrons, what you are going to do? You can easily find out the group. See, children, if the valence electron is 1, then you have to understand that it is belongs to group 1. If the valence electron is 2, then it is belongs to group 2. But if the valence electron is 3, 4, 5, 6, 7, 8, don't consider them. It is belongs to third group, it is belongs to fourth, it is belongs to 5th, 6th, 7th, 8th, like that. Because in this class we are not studying group 3 to 12. 3 to 12 we are not studying. Clear? So that is the transition elements that we are not studying as of now. So we are directly going to the 13th group. 13, 14, 15, 16, 17 and 18. In this class we are studying only first group and second group and the 13 to 18 group. Only these 8 groups we are going to study. Clear? Remaining 10 groups we are not studying. So for that purpose, what you have to do? If you find that any element with the valence electron 3, what you have to do? You have to add 10 to that particular valence electron. For example, you are having a boron. Okay, what is the atomic number? 5. So valence electron 2, 3. So now, if what you have to do? You need to write, you have to add with a 10. So 3 plus 10, that is 13. It is belongs to 13 group. For example, you are having sulfur. What is the atomic number of sulfur? 16. How you are going to write its electronic configuration? 2, 8, 6. So how you are going to find its group? So 10 plus 6. It is belongs to 16th group. So based on this you can take n number of examples and you can calculate. Clear, children? So now by knowing its valence shell, we can identify the period. For example, children, how you are going to do sodium you take? What is atomic number? 11. Okay, so how you are going to write its electronic configuration? 2, 8, 1. That means K, L and M. So 3 shells are there. So if there is a 3 shell, then what you have to do? It is belongs to third group. Take hydrogen and helium. Take hydrogen and helium as example. Hydrogen K1. What atomic number is 1? Electronic configuration is K1. Yeah, 1. Simply 1. So only one shell is there, that is K. If you take the helium, atomic number is 2. So it will be K2. Yeah, simply 2 you can say. Clear? So only one shell is there. So that's why hydrogen and helium belongs to first period. If you are talking about the second period, so second period elements, that means lithium is there. So what is atomic number? 3. So 2, 1 is there. 2, 1. That means it is belongs to second group. So that means what, children? If you want to find out the period, you have to see its valence shell. How many shells are there? Based on that you can give the period number. Clear, children? I hope you understood. By knowing the valence electron, you can find out the group easily, and by knowing the valence shell, you can easily find out the period. Clear, children? So based on that, you can take n number of examples and you can do yourself. So I hope you understood each and everything what I have explained. Okay. So whenever it is necessary, write and understand. Clear? Take more example in order to get more clear about the topics. So until my next video, keep practicing with the numericals by taking the examples. Okay, many examples you can take, many elements you can take and you can find out. Clear? If you like this video, please do comment, and if you are new to my channel, please do subscribe to It's My Science Cafe and click on the bell icon to get notification of all my videos. Thank you.